but there's actually very little research that sort of connects these two fields. I mean, it's almost surprising actually how little you see sort of things like pricing. The one exception I would say you hear about pricing is the ad auction stuff. People in machine learning have gotten very excited about ad auctions and you know, deciding how to price ads. But other than that, I would say there's actually very limited research on sort of, you know, trying to do sort of solve econ-related problems with machine learning. And I guess the first question to ask is ideas about why that might be. Any thoughts on sort of the surprisingly tenuous connection between the two fields?
Closely guarded secrets in banks.
That's probably true, yeah.
Economists think of equilibrium and know how you get there.
Yeah, I think that's a good point, actually. Somehow economists are surprisingly uninterested in complexity issues and algorithmic issues. So when they look at equilibrium, they say, oh, look, it's obviously the solution of some complicated differential equation or whatever. When, of course, that might, that it might be impossible to solve that difference. What's that? Who is? What? Yeah. Oh yeah, more and more these days. Yeah, sure. And I think the good thing is you have people like Christos and lots of computer scientists are now crossing over and talking to economists. And you also see a lot more sort of like the mechanism design community, which hasn't really merged with machine learning so much. Although you're seeing more and more of that now, like Alex's talk earlier. Anyway, so I mean, that was one issue I wanted to.
So it's not entirely economists to blame, though, because we haven't spent much time looking at that. And maybe one of the problems is that, in computer science, the idea that you might kind of look at a paper more than 10 years old as something, that's obviously passé. Whereas if you're actually going to take economics literature seriously, there's a hell of a long to go time. Sorry? Might actually do, yes. So I mean, I think in a certain sense, economists don't care about machine learning, and at least historically. So it's our job, in a certain sense, if there are connections, to make those, at least initially. Yeah. We've maybe just been slow.
It's a bit surprising you say that. I mean, most of the research in economics on modeling agents always takes a Bayesian approach. I mean, essentially, it assumes that sort of everyone's Bayesian, and all this early work on sort of mechanism design assumed that sort of everyone's design, everyone's utility for an object was sampled from some distribution, and everyone knew that distribution. So, I mean, they're using the same techniques as we do, but somehow there hasn't been. So, we speak the same language actually, people who do sort of that side of statistics or machine learning. But there still seems like there hasn't been that much connected work.
Kind of the same language. Their jargon is entirely different from our jargon. Economics papers are really hard to read.
Yeah, I mean, there's always a cost in crossing communities.
Theoretically.
Yeah, I mean, one of the things that I came to mind was this fact that like we often we tend to assume in machine learning that we receive data in this from a world that's basically just spitting out things in this sort of IID process, right? And so when we get a label, it must have been it must have been given to we essentially paid someone to get that label, and they were very careful, and they essentially just told us exactly the truth, right? Or maybe with some noise. And essentially, every time you look at every time I start working on an applied machine learning problem, this is never true in a fundamental way. And I remember going to talk to a children's hospital recently, and they said, yeah, if you look at like the diagnosis, so you take some data on a patient, you look at the diagnosis of the patient, it's essentially always chosen by the doctor to like maximize insurance benefit, to essentially get more money from the insurance company. And you're told don't trust the diagnosis. Like you think that's a label, that's not a label at all. It's a meaningless label. And like Netflix prize, if you ever used Netflix before and you're actually like labeling movies, usually you're punishing the algorithm or you're rewarding the algorithm. You're saying, oh no, okay. You really shouldn't have suggested that movie to me, so I'm going to really give it a bad score, right? Oftentimes, the responses you give aren't actually, you're an agent, right? You're actually trying to like push the algorithm in some direction. You might push it too far. So, anyway, I wanted to kind of mention that idea.
I'm not so concerned about getting economists to work on machine learning problems, but having worked with them, it's okay. but the other way is I'm very interested in getting this community more machine learning people working on this. I think this workshop is a great start. So I'd really like to understand the obstacles you might be there for that. One thing I see, maybe it's a data thing. Machine learning problems are a data thing. But for market problems like this, what is the data? Where is it? Can we get some like go into track data sets, things like that? I don't know. It seems like that's a barrier for there. Otherwise, I don't see any actual barriers. I mean, it's all complex analysis at the root of it. So, when I was doing the work that I described in the talk, we were doing is a co-author's a machine learning guy completely. And once I showed him the mappings enough between machine learning stuff and what economists call these things, it was like a threshold phenomenon where at some point you could just do it like really fast. Really well. So, but yeah, one of the things we struggled with was, and he wanted to know, I was like, okay, how are we going to evaluate this? How are we going to evaluate this? That's just how he thinks. If you're going to build something, I need to evaluate. That's how this community thinks that that's awesome. So, yeah, I'm interested in what obstacles are there getting? I don't think it's theoretical obstacles or maybe jargon, but that can really help. But I think the data is a big thing. I was talking to anyone else earlier about, I like this idea about these contests you want to run to run machine learning models. At least there's something there's potential to generate more data there as opposed to getting people to put in these markets. Although with crowdsourcing, that's getting better. On the turns and stuff, you can start doing that on. Turn will get a lot of data, but otherwise it's very difficult to get data from different subjects.
Yeah.
I guess in the stock market data, you have that, right? You can hold a contest and then close it, and then let the stock market run on for another 3 months and evaluate who would have made money.
But that's not a pretty, well, I guess you can look at this prediction market, but that's been, we're talking about, a lot of these questions have to do with market design, so we're interested in designing new markets and how they do for like prediction. So,
What would that be in real life?
so
How would you design the market in real life? Would you go into prediction market, or what would be?
were you there for my talk?
Yeah.
Okay, so, you can go to prediction market and then run it. We're doing that for the US presidential election. So it's going
So I guess one of the questions is the definition of the problem. If you want to attract machine learners to the area, they kind of want to know what the question is. And one of the issues is there are just lots of questions, lots of different questions about they're related, but they're different. And the other question is, do those actually, how do we convince the machine learner who's used to thinking about one particular problem, maybe 2 problems in terms of a supervised or unsupervised learning of some sort, that actually this relates to the things that they care about. And forming that argument is not always an easy one in terms of making those connections. So there's one connection, as in the connections exist. The other connection is actually getting people to care that they exist. And that's a different matter.
I was quite interested in the thing we did about combinatorial odds of connected events. So I've seen that in practice with the UK national elections, where there was the Green Party had no seats, and so there was an item which was, will the Green Party get at least 1 seat? And then there's a particular location on the south coast where the incumbent candidate was very unpopular because of an expenses scandal, and the odds of the Green Party candidate was something like 80% likely that she would storm it, and in fact that's what happened. But the pricing nationally was the Green Party unlikely to get any seat at all. And obviously, if you put those two together, there's clear risk-free, free money, effectively. I didn't take advantage of it, but it was out there, and that's an example from the UK. And so the idea, the bookmakers don't use these techniques, And it seems their aim is to balance their books, so they just want customers who will bet each way so that they don't need to do arbitrage externally. I was surprised at the result that Wall Street maybe don't do that, because for example, for an exchange hedging of currencies in 3 different pairs, I think the market's fairly efficient, will close down that inefficiency pretty quickly. So I guess talking about Wall Street, the example was maybe in stocks, where that might not be the case. So the question is, why aren't bookmakers interested in these machine learning techniques instead of giving away free money?
I think there might be, but it does tie. I mean, UK bookmakers built everything on horses, and on the whole, horses are independent events. One race, the next race. So, as people start putting more money on more interesting things, maybe they will become really interesting.
This solves how to get machine learning people interested in become technically.
If I see something like that again, I will take.
There has been a lot more interest in the recent years from their side of how to use this as well.
So we got to prediction markets. I did want to make one point, which is interesting, which is I think a lot of this interest in prediction markets recently came from, so people did aggregation methods in machine learning. This has been going on for years. You've been reading about aggregation, bagging and boosting and these kinds of things. And only recently people have started to think about prediction markets as sort of like an aggregating method. And it's kind of a weird aggregating method because, the prediction markets that are out there now are not, they're sort of designed to give traders, people, the opportunity to bet, and of course to make money off of, commissions and things like that. I feel like there hasn't been a lot of thought on, how do you try to maybe use a market techniques or a market model to get algorithms to combine. And that's something that I think is starting to be kind of an emerging area of research. And I mean, Adrian's talk this morning was an example of that. And I guess I asked myself this question, which is that is there a reason, there's sort of a reason we don't do things this way. We're sort of adding more complexity. When you sort of add incentives, you kind of add more complexity. A grad student can take all these algorithms and just run them on their computer. They don't need to think about the incentives of the algorithms or the person holding those algorithms. But I mean, I personally think that there are some advantages to thinking about aggregation in terms of incentives in markets and things like that. But I guess I was going to throw it out there to see if you guys had any thoughts about this. This idea of sort of using a prediction market as a way to combine algorithms and combine lots of different techniques.
I think one advantage it potentially has is when you define the interface of these algorithms in terms of trying to maximize a single scale of value, or money if you like. I think you open up the possibility of dealing with more heterogeneous data on the learn. So you could start. I think a lot of aggregation techniques in machine learning, like boosting and bagging and everything, the feature vectors or whatever you're using have to stay the same across all of the algorithms you're aggregating. I think these approaches could potentially open up more diversity in the kind of things you aggregate.
So I think one of the questions is what's the win? Because at the end of the day, you kind of end up with a computational technique, and so when you just define it, so you can think about it in terms of markets, but then if actually what you end up with is something that's just some method of combining stuff together, the question is, what does the actual market give you? Does it give you something beyond just actually running an algorithm? So why do we care that it's a market doing this? And there must either be a driving principle, which means that actually thinking about these things in this way produces better algorithms as a result of this way of thinking about things, or that actually thinking about them produces your computational advantages in terms of parallelization and scalability. And I think, again, if you want to convince machine learners that this matters in terms of the way of thinking about it, somehow there must be a payoff of it. A review of one of my submissions at one point just said, "Where's the meat?" The question is, what is it that we have now in terms of utilizing these sorts of things?
Yeah, think maybe one answer, at least in the short term, is it's analogous to, I guess, the way early machine learning drew inspiration from biological mechanisms learning. I mean, we've moved beyond that now, but I think it was quite useful in the early stages. And one suggestion might be that taking market interpretation of these things will spur a bunch of new ideas, which might be later turned back into standard algorithms. I think there's value in the interpretation at the front.
The specialism that you get in social organisation, which comes from markets, you have individuals that are able to produce very specialist goods that can then be combined with other goods and things like that. It seems a function of markets that enables this to happen. And actually, it's one of the things we desperately need in machine learning is to actually be able to take something and cut it apart into pieces and be able to get algorithms that know what they're doing the bits, and being able to pull those things together, it seems to me. And so if that kind of social construct can pull across, then that's what it seems to me.
Yeah, and this relates to something that Rolf and I worked on recently. There is actually an advantage to maybe doing it, having a market framework to combine sort of algorithmic techniques, which is that it's possible that in the not so distant future we'll actually have, the best machine learning methods for a certain task will not be published and will not be available for researchers, and they will be someone developed them in a company, and they may want to get credit for that, financial credit for that, and they're not willing to, but not willing to provide the actual algorithm, but they will provide predictions, right? In which case, having a mechanism gives them the opportunity to provide predictions without actually revealing what they, their code or whatever.
Yeah, I mean, along that line, once you black box the thing producing predictions, you also open up the possibility using these mechanisms to combine human predictions with algorithmic predictions.
Yeah. Yeah.
So I think one thing that's interesting is that it also gives you an equivalence between, it forces you in a sense to give an equivalence between the amount of resources that you're willing to sacrifice for a given level of accuracy in your prediction and the amount of resources that you use in carrying out that prediction. So if we start thinking about things like feature generation, it can be very computationally expensive, where you are not actually able to evaluate all potential feature generation mechanisms because it's like very unbounded. But if you actually know how much you value in prediction, this might provide a way of allocating those resources into the underlying computation resources that are going to get used.
I just find that a good point in general. Like we often talk about how well my algorithm did, and sometimes you hear people say, "Oh, well, I just stopped the optimization because I didn't have time or whatever. My results didn't. They or maybe they, for whatever reason, they just didn't finish the minimization of their objective." And the actual, you often ask yourself, well, don't you probably have some actual cost incentive, right? You actually have, everything costs you money. Every cycle on Amazon costs you money, and every percentage point of improvement also is valuable to you. And the question is, what's that trade-off? I think grad students probably don't make the right trade-off there. So if you're actually, if it all comes down to actual money, we know that people behave much more efficiently once things are being boiled down to an actual number, which is the amount of money.
That's also a very important point in machine learning, because we do things to death very often, and a very obvious question is, do actually any of the differences between all the techniques that we fight over, once you actually include the cost benefit into that, do they actually make any difference? No, or would you have all stopped after 4 iterations, produced the results and pump them out, and actually everything's as good as one another in this particular situation?
Yeah.
It's often an unsaid thing, and obviously depends very much on its precise application of what you're using.
Yeah, that's a great point.
I guess at a higher level, what you're saying is something like markets allow you to compare apples and oranges because you can turn them both into dollars.
Yeah, they get turned into money. Whenever they get turned into money, you're...
Yeah, and so now you have a mechanism for comparing the value of prediction to the resources required to improve that prediction.
Yeah, in a very direct way.
Well, I just have a small question. Concerning the prediction market, is it possible to introduce more complicated financial type of derivatives on that market. And currently, it's only like someone can buy the prediction stock at a certain price. But eventually, what happens if the financial markets is like complicated derivatives actually come in, make the thing actually more unstable, sort of speaking. But do you envision that those kind of things could happen for, say, prediction market, like someone sells an option or something like that?
So there's a direct corollary between that and feature creation within the machine learning context. We tend to deal with things as a set of random variables, but very often we don't work with those random variables. We compute features of those random variables, come up with those instead. So that's creating effectively a derivative good from the goods that you have in the first place. So yeah, I think that's.
I guess how would you interpret that? Like, there's a very clear interpretation here from the prediction markets. How would you interpret the pricing of an option? What does it correspond to in the real world?
Good question.
Yeah. Good question.
We could start with Black-Scholes and then go from there.
Crash the prediction market.
If your question is whether you can go beyond 0-1 securities to much more complicated securities, then yeah, you can start to do that. A stock is something that doesn't pay off 0-1, it just pays off whatever the price of the stock is eventually when you decide to sell it. And for that kind of security, what you're eliciting is not the probability, but actually your expected value of the stock, just your straight out expected value, which is a probability. You can do that much more. You can design securities for more general kind of expectations, including overall. But there's still options and conditional probabilities, things like that. There's big open questions there. There's initial probabilities we take.
Options would be interesting in this context, right? Because when they start to encode things that a single trader believes about the loyalty of all the other traders, in effect, you're saying, if the price reaches a certain level, then you can make money right away.
There's also time-based elements. The closer you get to expiry, then your range of values, your confidence will change over time.
So those who don't know, a financial derivative or an option is like a contract which depends on some underlying information with the price of the actual about the underlying asset or what. But if you think about it in terms of, like, if I were to say this machine learning, I would say it's a feature which can depend on maybe both the label and the actual input. So you can think of introducing a new security as almost like introducing a new feature that people could actually sort of trade on, and the actual sort of value of the security at any point might be sort of a prediction of the actual final value of the. And so, I think this idea has been, people have thought of this before as kind of a cute idea as a way to. And there's this question, of course, is how expensive is it maybe to actually compute that value of the feature, and maybe that'll factor into the price of the derivative or feature. But I think it's a great question. Do you have something to say, Nikete? Do you have a comment to make?
So if you partition the space finely enough in terms of these irreversible securities, it's like 0-1 payoffs. So I think in financial markets they call them binary options. And there's theorems that basically show that you can replicate any arbitrary derivative that you want with a portfolio of binary options. The portfolio spans the underlying space. Now the underlying space is going to be big, and you can actually, you might have computational issues why you might want to work with the derivative directly, but in principle at least, the underlying binary contracts are surprisingly general. The other thing in terms of like thinking of, my initial intuition was that derivatives would be more like structured prediction tasks rather than, right? Because you actually you have a new target variable now, which is composed inside of all these other target variables.
Yeah.
It's not so much like, it feels like it's not so much a new feature that you're going to have, but rather this new output that you're trying to target, which is composed of these other things. So maybe there's connections to algorithms for reduction from structural learning to binary prediction. Maybe they can be used for reducing these complicated contracts into simple binary contracts that we're better able to price.
Any final thoughts before we convene? So I guess.
Thank you all for coming along. Yeah, I mean, it's been a good opportunity to discuss a wide variety of different things, but that actually do connect together. And I think the aim of this workshop was to give opportunities for people to connect these things together and see other things that maybe they didn't know about, and hopefully we'll have more of these opportunities, because I think it's important and necessary, because I think there's a lot of room for interaction. I think when it kicks off, then we'll see some very interesting things that come out of it. So do carry on talking to one another in the meantime, and we'll try and make sure that other opportunities arise for similar sorts of things. Thank you very much.
Thanks, everyone.